Welcome to this video on accessing computer input-output devices. In this session, we will explore how computers communicate with the input and output devices, the critical components responsible for interacting with the external world. From simple keyboards and mice to more complex peripherals like printers, monitors, and network devices, input-output devices play an essential role in computer functionality. Input and output devices act as the critical interface between the user and the computer system. An input device is any hardware component that sends the information to the computer for processing. These devices allow user to provide data, commands, or signals to the computer. Some common examples include the keyboard, mouse, microphone, light pens, barcode readers, joysticks, and trackballs. Other hand, the output device is a hardware component that receives the data from the computer and reproduces it, allowing the user to see, hear, or otherwise experience the results of the computer process. Examples of output devices include the projector, plotter, monitor, printer, and speakers. A bus is essentially a set of wires that enables interconnection where each wire can carry one bit of data at a time. It serves as the primary communication pathway through which data, instruction, and control signals travel between components. Buses can be classified into two main types. The internal bus, also known as the system bus, connects the CPU, memory, and internal components. The external bus connects the computer to external peripherals such as printers, external storage devices, or network interfaces. The internal bus, also known as the system bus, connects key components within the computer including the CPU and system memory. It is responsible for ensuring smooth communication between the processor and the memory, allowing the data and the instruction to flow efficiently within the system. In contrast, the external bus, often referred to as the expansion bus, connects the computer to external devices and peripherals. These include input-output ports, drive connections, and devices such as printers, external storage, and network adapters. The external bus extends the computer's capability by allowing additional hardware to interface with the system seamlessly. A system bus or expansion bus comprises of three kinds of buses: data bus, address bus, and control bus. The command to access the memory or the input-output device is carried by control bus. It is unidirectional from CPU to all other components. The address of input-output device or memory is carried by the address bus. Address bus is unidirectional from CPU to all other components. The data to be transferred is carried by the data bus. It is unidirectional for input and output devices and bidirectional for memory and CPU. Each input-output device is assigned a unique set of addresses. When the processor places a particular address on the address lines, the device recognizes this address and then responds on the control lines. When the processor records either a read or write operation, then the recorded data are transferred over the data lines. When input-output devices and memory share the same address space, then the arrangement is called memory mapped input-output. Most computer use systems uses memory mapped input-output, but some processors have special in and output instruction to perform input and output transfers. Example, processor in the Intel family have special input-output instruction and a separate 16-bit address space for input-output devices. When building a computer system based on the processor, the designer has the option for connecting input-output devices to use the special input-output address space or simply incorporating them as a part of the memory address space. One advantage of using separate address space is that input-output devices deal with fewer address lines. Address decoder has two or more inputs for address bits and one or more outputs for device selection signals. Enables the device to recognize its address when the address appears on the address lines. Data register holds the data being transferred to or from the processor. Status register contain information relevant to the operation of the input-output operation. The address decoder, data and status registers, and the control circuits are a record to coordinates input-output transfer constitute the device's interface circuits. When a human operator is entering characters at a keyboard, the processor is capable of executing millions of instructions between successive character entries. An instruction that reads a character from the keyboard should only be executed when a character is available in the input buffer of the keyboard interface. For an input device, for example keyboard status block, SIN is included in the interface circuit as part of the status register. For an output devices, for example display status flag, SOUT is included in the interface circuit as a part of the status register. Striking a key stores the corresponding character in an 8-bit buffer register associated with the keyboard. 8-bit buffer register is known as data in. To inform the processor, a valid character is in data in a status control flag SIN is set to 1. A program monitors SIN and when SIN is set to 1, the processor reads the content of the data in. When the character is transferred to the processor, SIN is automatically cleared to 0. If a second character is entered at the keyboard, the SIN is again set to 1 and the process repeats. A buffer register data out and a status control flag SOUT are used when characters are transferred from the processor to display. When SOUT equals to 1, the display is ready to receive the character. Under program controller, the processor monitors SOUT. When SOUT is set to 1, the processor transfers a character code to data out. The transfer of a character to data out clears SOUT to 0 when the display device is ready to receive a second character. SOUT is again set to 1. Data from the keyboard are made available in the data in register and the data sent to the display are stored in data out register. Two control flags SIN and SOUT which provide status information for the keyboard and display unit respectively. Two flags keyboard interrupt request and display interrupt request are used in conjunction with interrupts. Thank you for watching.